things. Has anybody suffered major shock coming back? It was so weird yesterday. I got so in the groove. I went up to a little coastal town I'd never been to before, and I was like, now get me this. A lot of this stuff I took with me, and like in the morning I would go to the cafe down the road, the Luna Cafe. I would set up, grade, do stuff. And then the rest of the day I hiked and I ate and I drank and it was great. So hopefully you guys had a good break. If you didn't, I'm sorry. Looks like many of us didn't make it back from the break. We'll see if they stumble in eventually. So what I want to do today, obviously today is review day. So the practice test is there, you've got the quizzes you could ask about. Everything's on the table, whatever you want to cover. What I wanted to do first, though, is I thought I'd give us a little more structure. And because all of us really, really love group work, I wanted to start with smaller groups than normal. I was going to have like 2 people get together, I think. I'm going to try this. For the first whatever many minutes, I want to put groups together, and each group is going to work on a different problem for the practice test. And then you're going to present it really quickly up on the board. Is everybody with me? You all understand what I'm saying? So let's see, 2, 4, 6, 8. Oh my God. At this moment, we have an even number of people, which is amazing. The universe does have a sense of humor. Okay. So let me make sure one more time. Everybody's got a practice test, yes? Do you have it right now with you in front of you? Can you get the practice test? D1? Anybody else need a practice test? D1? Do. Everybody else good? Okay. So let's do this. Let's see. Pair you guys up. Let me see that. Let's have. Trying to wait to see if anybody else is coming. Let's get. All right. Let's get Dylan. Can you work with Hanita? You guys work together. There's Dylan right there. See? Okay, good. Layla, can you work with Magda? Okay. Let's see. I gotta get track of everybody. Oh, here we got one more person. Yay. Jayun, do you have the practice test?
Yeah.
Good. Get it out. I'm gonna put you with somebody in a minute. Here, Kevin and Ilya, you guys work together. What do I have left? Perfect. Ronnie, can you work with, forget your name, I'm so sorry. The worst person in the universe. Huh?
Yes, Arzo.
Arizo?
Yeah.
Arizo. Okay. Let's see how long this takes a minute. Ronnie work with Arizo. And then who do I have? Giant. Can you work with, I'm going to say it wrong, Rasheen. I always lose that coin toss. All right, so now I'm going to assign a problem to each group. Or let me ask you, all right, I had several ways I was going to do this. I'm going to try to make this decently compatible. Yes, okay. Can I have you guys work on number 9? Can I have you guys work on number 11? I want you guys to work on 12 and 13. Yes? See you guys back here, if you would please, can you guys work on 3 and 4? And then you guys, can you work on number 1? All right. Christine and I are available to help Did I start this going?
So, for 12, we have this log and we need to rewrite it as a single log. So we need to just combine the two and then simplify it. So let's see, the first thing that we can do is we can apply the power rule. So let me just, I just need to rewrite the whole thing first. Here we can apply the power units because this is not stable. Like this, and then we can move the 2 here and put it to the next one. And then so we're going to take this 2, so we can just have 1. And then move this 2 here, so that's the quotient, or not the quotient, but the power rule. And now we can do quotient rule, so we can combine them. So we have subtraction in the middle, so we can turn it into a fraction instead. So now we're going to have this. We're just moving all of this into fraction. Just have this. Just parentheses again. Next one. Square. And then we can factor. Huh? This one. There's a 5 right there. We have to write that. Okay. We'll just write that again. We can factor the top. So all I did is just factor the top. Now we can have these 2 cancel. And then we're just left with y base 5, which is just 1.
You. Any questions from that? There was, like, his factoring, he skipped a couple steps, but if you take the 5 out, you can then factor what's left. So that's perfect. So once you put a log together, the inside now you can consider as its own problem to see if you can reduce it. All right. Thanks, Ron. That was perfect. Leave that up there. I might want to reference that later. I still got you on camera. It's okay. Wake up more. You just.
Here we also broke out the square. And here we use the power rule, like 1 plus 2.
The one thing you gotta be a little careful about is that 1/2 power should apply to everybody, right?
Yeah.
There you go, cool, okay. There you go.
And finally the answer is 2.
flourish at being 11. And one little thing right here, you guys see how this is cool because you can distribute the power to both. Yes. So you could take the one hat down right now. Yeah, I know I'm always lying, but it's not good. You could take the one hat down right now, and then it would distribute to each piece, so it will still be in both, just in case you did it that way. There's multiple ways to do these problems. Sweet. See, that was smart. This group was like, let's do it and get it over with. Dear God. So you guys are done. Yay. Who wants to go next? Anybody? Everybody's gonna go. Yes, okay guys. Come on up. You can either do it on the overhead if you want, or you can do it up on the board. Let me just get this real quick. If you erase this stuff here. Doobie. And, you know, guys, this is all part of the review, so if you have a question about any of the work that's done, you can ask the guys who did it, or you can ask me, right? I want to make sure that we get everything understood. So you guys are next? Yes? Coming up. What do you want to use? The overhead or the board? The board? I don't blame you. I miss my chalkboards because I'm an old guy. What?
Which ones are we doing? Which one?
I can't remember. You guys are doing the law? No.
13 and 14.
Oh, that's right. They're doing the divisions. Right? Let's see. Yeah, the divisions. Oh, this is going to be interesting. I just realized. The reason I say that is, in America we have, and a lot of countries have a certain way to do division. There's a lot of countries that do division very differently. They set it up differently. The steps are basically the same, it's just the way they write their work is different. So we're about to see that. It's very exciting. Now, keep going, I'm sorry. I just want to make sure. As you watch this, do you see how it already looks different than the way that we did it? There's not a damn thing wrong with it though, it's beautiful. It's just the same work. Do you see where she wrote the X squared underneath? That was the X squared we would normally write up top. Yeah. Should it be a... can see how you get the same elements, just in a different position, right? Any questions from those problems? Oh, Laylee, you got yours, yeah. Coming up. You doing up here? Here, stand back. Let me grab that real quick. Sorry. Thank you. All right, cool. Go for it. After the 12x. You're good. Sweet. Alright. So that's what you, hopefully, you guys agree that if you're going to get a division problem, you want it to be synthetic. There's a lot less writing, yes? You guys with me? Don't forget your zeros in case I give you something, and you know I am, where you're missing a term. You have to have that zero placeholder. And that really messes up synthetic if you don't put that there. Because everything kind of ends up lining up with the wrong thing. It's terrible. Cool. Let me grab that real quick. Who wants to go next? You guys? All right, cool. Where do you want to go? You want to do board or overhead? Board? Okay. This is awesome. Oh, they're just going. All right. So we have two things. Don't forget your, careful. Now, can you very quickly explain?
So basically, the domain of an exponential will always be negative infinity, positive infinity, because it's the inverse of the logarithm's range. And then the range, by default, in an exponential will always be y equals 0. Because of the horizontal asymptote being y equals 0. But there's a shift by 2. So the range would actually be 2 infinity instead of 0 infinity.
Does everybody see that? So if I have an infinite thing going left and right, the only shift that will change it is up and down. If I move it left and right, it's basically the same. So since it's shifted up 2, now it starts at 2, and everything's above 2 because it goes up. Yes. Kick ass. Oh, please, dear God, ask questions if you have. Ilian, what do you have over there? Let's see. That first step, the domain, what'd you do to get there?
I said that x cannot set x. If I said 5 minus x cannot be equal to 0, so then I carried the 5 over, and I got x cannot equal 5. And since that would be the domain, would be the inverse of the range, it would be okay. First of all, I mean that would make the domain negative infinity to positive infinity.
Well, all right. So a couple things. The way you've got it set up, you said that x can't be 5.
Yeah.
So at least 5 should not be there, right?
Yeah. And
So it can't be all real numbers then. But secondly, okay, what kind of numbers can logs not handle? And you're fine, Ilian. Don't. It's always weird to be on the board. That's fine. What kind of number inputs can logs not handle? It can't handle negatives, or it can't even handle zeros. It can't do it. And what's going to help you out a ton, this is why I try to make a semi-big emphasis on this. If you remember how a graph looks for a function, a lot of questions about the function become easier. So, right here, don't say not equal to 0. Say greater than 0. So remember, if I give you a function and I say what's the domain of this function, just say in English what has to be true. The inside has to be greater than 0. 5 minus x greater than 0. Careful now. Careful.
The opposite way.
Yeah.
This one.
Because if you add x, then it'll be on the other side. So it should be less than. Yeah. So now it'll be all numbers up to 5, not including 5. Is everybody with me? You guys semi with me? Okay. So every log, the inside has to be positive. So whatever the inside is, you just say that greater than 0, and you solve, and then you get your domain. Okay. Now, one thing that you said, Ilian, the range for a logarithm is equal to the domain of an exponential. Why? How do logarithms and exponentials, how do they relate to each other? We can do this. They're inverses. What do inverse functions do primarily? They take the x's and y's, swap them, yes? What's domain? What is the definition of a domain? You could do it. You could do it. Does domain relate to inputs or outputs? Inputs are what variable normally? X's. Okay. Domain is x's. Range is y's. Yes. So what would an inverse function do then? It would take the domain and range, swap them. Because what does it do? It switches x and y's. Domain is all the x's I can use. Range is all the y's I get out. If I have an inverse function, it literally just does that. So if the domain for an exponential is all reals, the range for a logarithm is all reals. And what's a log look like again? Can you guys do it in the air? What's a logarithm look like? Sort of. Yes. What's going on here? How far does that go down? All the way. And then what happens here? How far does it go up? Forever. So negative infinity to infinity is the range because it hits all the possible outputs. So your range should be negative infinity to infinity. Cool. I like the way you're sorry. It's always weird. Yeah, infinity is kind of a weird symbol to get down. I always start like, I'm sorry, I don't mean to be big on you. Start in the middle, kind of go like that, right? But you keep doing you, man. I like this. It looks like a little like, oh, I don't really exist anymore. Okay. Sorry, I don't mean to be big on you. Let's see, who's left? You guys haven't gone, and you guys haven't gone, and of course you guys came late and you're like, I escaped your trap. You guys want to go? Come on. Let me grab this real quick. So you guys, we're just doing, I split everybody in groups and I gave them each a problem for the practice test. Do either one of you guys need a practice test? Do you both have one? Yeah, okay. You guys are doing which problem again?
Number 1.
Oh yeah, number 1. Okay.
So how would you want us to do it? Because I know there's a graph.
Oh yeah, if you want to do it on the overhead again,
Okay.
because then you can just put the paper down and plot it right on the graph itself.
Okay. Do you want me to?
I forgot how I put this. Did I say? Yeah, alright, so the idea is transformations. And I still have some people having trouble finding out what the base function is. If you can see the transformations, you have to be able to see what the base function is. How many transformations are there in 10A? How many? 3, good. What are they? Sure. What's a better way to say that? What's that actually do to the base function?
It reflects it.
Reflects it. So reflect across the.
Y-axis.
No?
Or not axis.
I think he said it, but I almost heard you. What does the +2 do up here? Left 2. And then the last thing you do is down 3. Now, if you remove each of those transformations, that is the base function. And which only makes sense. The base function is what I'm applying transformations to. So if I remove them, what I'm left with is the base function. Now, I always get somebody tell me it's been stretched by 2. No. 2 to the x is the base function. The 2 itself isn't doing anything. It's part of the function. Okay. So, what points do I use for the base function? Base function is 2 to the x. What points do I use? I have 3 anchor points that I want you guys to always use. So you have enough points to kind of move around. What do I use? So pretty much, I always want to use a negative number. I always want to use 0, and I always want to use a positive number. So -1, 0, 1. What's 2 to the 1? 2 to the first power. 2. What's 2 to the 0 power? 1. What's 2 to the -1 power? 1/2. So there's my base function, and my asymptote is currently here. Yes? You guys with me? I still have a few people that don't graph the base function. That's huge. You have to graph the base function. Because the only way to do this by hand is to give yourself points to move. So now I just pick a point and I do those 3 things to it. So if I pick this farthest point, what do I do to this point? You reflect. Shabo! Left 2, down 3. Bam! There it is. Take this point, reflect, left 2, down 1, 2, 3. This point, you gotta be a little careful because it's halfway, right? Reflect, left 2, down 1, 2, 3. And where's my asymptote gonna be now? It was at 0. Now it's going to be a -3 because everything went down 3. Gee-ha. Oh shit. Poor little guy. Okay. Bye. Hey, bye. How's that? Yes.
Can we clarify just for the base graph, what numbers that we have correspond to what points?
Sure. For the base, we use the points.
Or rather, maybe a better question would be what numbers in the original function correlate to which transformation?
Oh, so this is like A, B, C, A, B, C. Is that what you mean?
Kind of, where we have 1 with left x-axis, 2 left 2, 3 down 3. I think number 1 is corresponding to the exponent that we have. the.
Oh, you mean where this came from?
Yeah.
Oh, this is a reflection because of that negative.
Okay.
This is left 2 because I'm adding 2 to my input, so all my inputs are going to be 2 smaller than they used to be. And of course, this is just taking all the old outputs and taking them down 3.
Yep.
Yep. Sorry. All right. So everybody, we all know an exponential looks like this. So after transformation, it could open down, it could be reflected the other way, but it always has kind of like this shape. And a logarithm has this shape. Yes? So on part B, I didn't really do too much to this because logs are freaky already. But what are the 2 transformations? Left 1, and then down. And my base function, log base 5 of x. And I pretty much use the same ideas for the 3 points, but I'm gonna input stuff that works well with 5 to get those numbers out. So for example, 5 works really well with 5. So if I plug a 5 into the base function, what do I get out? What's log base 5 of 5? What power does 5 need to become 5? Like, I got one lower group back here going, slide into first. Okay. So 5, log base 5 of 5 is 1. What's log base 5 of 1? 0. And what's log base 5 of 1/5? 1/5 is -1. And that pretty much shows you where the asymptote is. It starts off here, yes? Is everybody with me? So now I've got 3 anchor points to move around. They're kind of like my skeleton. And then I can put the, it's 4, the flesh of the function on. Anyway, we'll be right. So if I take any of the points, I'll just do the 2 things to it. So I can take this point, left 1, down 1. This point, left 1, down 1. This point, left 1, down 1. And my asymptote is going to end up where? X equals -1, because everything shifted back 1. So now I look like this. Yeehaw! That's a little trippy because they're really close to each other, but oh well. Is that okay? Alright. So let me go ahead, I'm going to go ahead and give you the answer key so we can see if there's any questions from that. See if I got them all right. You never know.
I was also wondering, did you go over number 5? Because
Yeah, sure. That's somebody, wait, that says Usher. Use that line. I think so. So which one are you talking about, number 5?
yeah.
Oh yeah, it's a 5. This one's a little bit evil because Descartes doesn't really help us too much. How do I construct the possible rational roots? What do I have to look at? How do I construct the possible rational roots? What do I look at? What you do, Jeff, is you look at the polynomial in its entirety. Think about where it's been. No. Come on. Oh, okay. Guys, how do I make the list of possible zeros for that polynomial? Create a list. So how do I create the list?
Take
48.
Yep.
And I find, and 2. And what do I do?
Find all the factors
Factor, okay. So if I take all the factors of 48 and I divide by all the factors of 2, oh God, let's see. There you go, Jeff, look at you go. I didn't need the extra plus or minus, but we'll be all right. Now, listen. On one level, this is memorization, but do you guys remember why this makes sense? Why does this make sense? Does everybody agree? Now, this is not necessarily true, but if we guessed, could this be, you could do it, Jeff, could this be a factor of this? Could it be? Not is it, just could it be? You guys see that? Because then the other ones could be x plus something, x minus something. All I need is the x stuff to multiply by 2x to the 5th. And the numbers to multiply by 48, correct? Now, what's the root? What's the 0 associated with this? What would the x-intercept be? What would the 0 be? What would make this 0? You would add 3 and then divide by 2, so what would you get? No, add 3,
-3.
divide by 2, yes? 3 is a factor of 48, 2 is a factor of 2. So of course, the top are that come from factors of 48 because they're at the end. They're the things you add or subtract. The first numbers give you what's on the bottom because they're the things that you would divide by when you're solving for each 0. So it only makes sense to make a list of every possible damn thing it could be and take all the factors of the last 2, divide by all the factors of the first 2. Because that's how you would construct each possible fractional answer. And of course, a lot of them are in fractions, thankfully. I can do all of these divided by 1. Oh my God. And then I got 1/2 and 3/2. I think that's the only new ones. That's a pretty long ass list, right? I did give you more information here than normal. How do you show that 6 is an upper bound? How do you do that? How do you show that?
You put the function into synthetic division function.
Good. You do synthetic division using 6.
Yeah.
And what am I looking to have happen? To make it a upper bound.
To see if the outcomes are
If they're all the same sign. To be really honest, in general, they could all be negative. As long as they're all the same sign, and I divide by a positive number, that is an upper bound. Are you guys with me? So let's see. I'll do a little quick, you can all see it on there. At some point, do I kind of give up on it? I think I do, right? This is big positive, big positive, big positive, big positive, yes? I know it's not going to be 0, so at some point I'm like, I don't care what the end result is, I just care about the signs. What does that mean? What did I just figure out? Good, what does that mean? Specifically, what does that mean? You do it. What does upper bound mean? What does that tell me will not work? Give me a number that won't work now.
6.
6 won't work. I love it, Ryan. I love you. 6, you can just see it right there. 6 doesn't work. What else doesn't work? 8, because 6 is an upper bound for the possible answer. So anything above 6, 8, 12, 16, 24, 48, we just eliminated 1, 2, 3, 4, 5, 6 answers with 1 synthetic division. You guys with me? The list is still pretty damn long. Okay. Is everybody with me? Yes? What does it mean to be a multiplicity, a 0 of multiplicity 2? What has to happen? Do you see where it says show that -2 is a 0 of multiplicity 2? What the hell does that mean? What does that mean? What should happen synthetic division-wise? It should work twice. Has everybody tried this problem? Has anyone not tried this problem yet? If you have not tried this problem yet, please synthetically divide this by -2. Go. Oh wait. was an adventure for me. I had a brain fart moment. I love it. You guys all with me? So I went in once. How do I show it goes in again? How do I show it happens again? Did you guys get that? Okay, at least one of you did. Good. How do I show it does it again? Yeah, do it again. Bam, right now. So I told you it works twice. So you know this is going to work. I just can't keep going. If I get something to work, never use these numbers again, ever. If I get something to work, these are dead to me. Because I've already factored it. I'm going to work with what's left here. Yes? So now, let's see how Jeff does. Oh, Jeff sometimes is able to divide and multiply and shit like that. Okay. So I've gotten the stuff down to, can somebody tell me what the highest power is in the answer that we have at the moment? What's the highest power in this answer? What was the power of the original problem? X to the fifth. So this would be x to the fourth. So this will be x to the third. There, you can follow what's happening. Every time you synthetically divide, you're losing an x when it works. You're losing an x. So if you did several, you're like 5, 4, 3. Okay, cool. But now the only thing now, the way I've set this problem up, Descartes didn't tell us shit, but I gave you more information. I said 6 is an upper bound, you had to show it, but 6 is an upper bound, you can throw some stuff out. I told you that negative 2 works twice, you do it. Now you just gotta get one more number that works, yes? So did anybody happen to find another number that works? 3 halves? Let's see. 2, 3, negative 10, negative 15, 8, 12, 0. Yay! Now, help me out. And again, you know that there's going to have to be a fractional answer because the first number's a 2. There has to be a fractional answer. Somebody tell me what we found so far, our factors of this. What have we found? What do these relate to? What factors? X plus 2, and there's 2 of them, yes? Sure, x minus 3 halves. I know where you're going, we'll get there. And what's this? 5, 4, 3.
2x squared.
Good. 2x squared minus 10x. Do you guys see how there's a factor of 2 that can come out of this?
Yeah.
So I'm going to show you all the little ins and outs of where all this stuff comes from. I can take a 2 out of here, yes? Yes? And then I could put it in here. So that's where you get 2x minus 3, yes? You can see it coming out. And what can I do with this last bit here? We can leave them alone, Jeff. You're factoring all these poor little dudes. Maybe we just leave them alone. No. How do I factor him? There's only one way to factor 4 that'll make 5. 4 and 1. And they both have to be. What are my zeros? I can pretty much read them off from up there, but negative 2. Add 3 divided by 2, 3 halves. 4, 1. What would it do? What would the graph do here at 1, 0? What would it do? It would go through, bounce. Cool. I like it.
So
Yes.
to get the 3 over 2 for one of our numbers that work, how do we get there?
You try.
We just have to keep trying different factors.
Yes. Now, in the actual test, I will decrease the size of the list even more.
Okay.
I'll make sure that Descartes works, for example. That'll cut the list in half. But for the practice test, I figured we could only use a little more practice with synthetics, so you just gotta keep trying stuff.
Okay.
On the actual test, we have time limits, so I'm not gonna like, here's 20 things, let's see how you do. That kind of mean, not
Well, we
quite
have
that mean.
more room to write, or should
No,
should we use scratch?
screw that. No, I mean, the practice, you can write whatever paper you want to. That's your own thing. I don't care. So if I give you a test and there's not enough room, just use another piece of paper. Not a big deal. Yeah. Anything else we want to focus on? Yes. 8. Oh yeah, let's take a look. All right. Yeah, I figured this one might be a bit much to give to a group. So let's see. What, do you guys remember the very first thing, before you even start answering questions, what should the very first thing you do? Factor the top and bottom. Cool. So if you haven't done it yet, go for it. Factor the top and bottom of that problem. So I always get people that like overcomplicate the top here, but what really should be the first thing you do when you're trying to factor something? What's the first thing you should look for? GCM. That will save your ass. If you just think, look for that first, just first thing. Either it's the only thing you do or uncover something else you could do. So what can you take out? 2x. And then you're left with x squared minus 9, and then that factors to be x plus 3x minus 3 is equal. And the bottom gets you to this is as far as you can go. One little thing about the big dude I've talked about before, the big dude never factors. More importantly, the big dude will never give you real answers. Now what's a little unfortunate, makes me cry a little bit, but I'll be okay, is we're not going to get to the point in this class where I can show you, it's so freaking cool. You have a real answer, and then you have the two complex answers at different angles to the real answer. And that's why they're always complex, because they have to cut the whole thing in thirds. All of that doesn't make any sense, and I'm really sorry. But the big dude will never give you an answer. You'll only get one real answer out of a cubes. Now, what does the top relate to? What information does the top give me? How do I make a fraction 0? Like, how do I find the x-intercepts? X-intercepts are makes the output 0. What's the only way a fraction can be 0? If I put a 5 on top of a fraction, can I put anything on the bottom that would make the answer 0? 5 divided by what is 0? Is there something? No. So what do I have to make the top to make the answer 0? 0. What makes the top 0? So the top will always be related to the x-intercepts. What makes the top 0? 0. What else?
-3.
-3. What else? Positive 3. And of course, the y-intercept, we already know, but if I made x 0, I get 0 over, who cares? I get 0, 0. Yeah. So the y-intercept is 0, 0. Now, what does the bottom relate to? Why do we factor the bottom? So I can see what? Where did vertical asymptotes come from? Sorry, I was gonna say, well, no, asymptote. No. Where did vertical asymptotes come from? Why do we put a wall there? Vertical asymptotes are the wall. Why? Why would it put a wall at like x equal 2? Is there something wrong with 2? What value of x would make this function freak out? Would make him undefined? Is there a value of x that would make him freak out? Would make him undefined? Yes, do you guys see that? If I make x 1, what happens? It would be divided by 0. What's divided by 0 mean? Little black holes. Yes, we made a singularity, it's bad. Alright, so listen. I don't want you to memorize this shit, but if you want to, the top leads to x-intercepts. Why? Because the only way a fraction having an output of 0 is if the top is 0. The bottom leads you to vertical asymptotes. Why? Where do I have to put a wall? At the value I can't use. What values can I not use? Anything that makes that undefined. What makes that undefined? Bottom 0. So it's not memorization so much as just, I'm going to do what makes sense. I can't use a value that makes it undefined. I'm going to put a wall there. That's vertical asymptotes. So my vertical asymptote, what is it again? X equals 1. What situation are we in for the horizontal asymptote? Yeah, what do you look at? What do you check to see what situation you're in? The powers. The powers on the top and the bottom. In this case, the degrees happen to be the same. So therefore, how do I determine the horizontal asymptote? 2 over 1. So y equals 2. Asymptotes are lines. X equals 1, y equals 2, they're equations of lines. If you just say vertical asymptote equals 1, that's not good. You're not going to lose a ton of points, but you will lose some points. Okay. Why? Because I'm evil. You should know this by now. And then I gave you these because I'm just being a little nice. But if I plot what I have so far, 0, 0, 3, 0, negative 3, 0. Vertical asymptote x equals 1. I'm not going to do the horizontal yet because I don't know what my y scale is going to be yet. It kind of makes sense. If I need to know how far up or down negative 1 kind of goes. So that's why I said f of negative 1. And I said f of 2 just to kind of help you determine where things are happening over here. Let's see what happens. F of negative 1. Did anyone do this yet? See, I could just use this because it's pretty compact. Be negative 2 plus 18 over negative 2. And that would be, you could do it, Jeff. Negative 8, is that right? Yay, go Jeff. And then f of 2 would be 16 minus 36 over 7, which is negative 20 over 7, which is roughly negative 2.86 or something. It's the negative 2.9, roughly. Okay. So very exciting. Of course, you're going to have calculators. The part C will be easy. Do not graph it first. Do not graph it first. Do not graph it first. Because you're going to follow the graph in the calculator, which might not match up with your work, and that's the best way to lose the most points. Okay, so what does it look like my y-axis scale should be? And what are you looking at to tell? What's the biggest output that we got from all of our work? It's the biggest y value associated with anything. No. What's f of negative 1? Negative 8. So when I say biggest, I'm sorry, I meant most extreme. I should have said most extreme. So I want to maybe use by 2's, yes? So I can get down to negative 8. You guys see what I'm saying? There always seems to be some misunderstanding about how to determine what a good scale is. You never determine the y-axis scale until you're done with all the things I give you. But then you just step back and go, what's the biggest Y I got here? That I better make sure that fits. I don't want to see any freaking like, it goes up and comes. No. Pick a good scale. Everything's got to fit. Yeah? Trust me, it's up there. No, stop. So what do we got here? We got, now I can put in my horizontal asymptote. There we go. That's what I was missing. So now I got all my walls in there. How many regions did I break this up to? How many regions did I break this into? How many vertical asymptotes are there? How many vertical asymptotes are there? There's one. So there's two regions. Yes? So over here in this region, for example, it's either up here or it's down here. And obviously, did I plot my other 2 points? It's even better if I do that. -1, -8, and 2, -2.9. So now it's really in your face. How does it look like over here? Yes, I love it. So it's got to approach this asymptote, and then it's got to approach that asymptote. I get a few too many of you guys are doing stuff like it goes here. You got to show me, overemphasize. Show me you understand it's got to get close to the asymptote. Our graphs are not going to be exactly right. You're going to overstate them so I can see that you understand what's happening. The other side's weird as shit. Where does it have to be, like, back here? What's this all about? What's this all about? What's that mean? What's that dotted line I put in there? No, it can totally cross. It just has to eventually get close to it. So back here, it's got to be here. You guys see that? It's got to be here back here. And then, one little thing I didn't say, what's the multiplicity of each of the x-intercept pieces? So what's it going to do at each of them? It's got a multiplicity of 1. What's it going to do? Is it going to bounce or go through? It's going to go through. Good. All right. So I know, because of this asymptote, I've got to be up here. I know I've got to go through. Thankfully, because I've got to be down here, right? Then I've got to go through here. And then, what do I do from here? This is where people get freaked out. I don't care about this wall because is x big here? Is x big here? Is the value of x big here? No, it's like -1, it's 1, yeah? So I can go through it. I just have to get close to that vertical asymptote, yes? So that is a trippy looking graph. Now you would graph it in your graphing calculator. And as long as you got the basic look of it right, leave it alone. Don't go, oh, this should go a little deep. No. No. You should only graph what you know from your written work. That one's a little bit trippier than one I would give you on the test. That one gets a little trippy right here. And I don't blame you, it does get a little trippy. One I'll give you is going to be a little more regular, like the other ones we've done. I just want to give one that was a little more interesting on this. What else we got? Yeah, of course. I need you to understand that it does not matter what log I'm working with. Log base pi of 2x plus 5. Can somebody help me find the domain? Do you see how the base doesn't matter? We're shit. I don't care what the base is. What's got to be true of the inside? What kind of numbers can logs handle as inputs? Positive. So there's got to be. So the inside has to be greater than 0. The inside has to be greater than 0, and then you just solve the damn thing. What if I put a natural log in? Same. What if I put a 13 here? Same, right? Okay. And then of course you subtract 5, divide by 2, and then if you want to, you can write that as a yeehaw. Okay.
Can we also do
number 2. It's kind of similar to 5. It's just that I want to make sure I understand that as well. It's a long number.
Oh yeah, okay. To be really honest, I can't even remember. I'm pretty sure I showed you how to do this, but I didn't even bring any calculators.
I was kind of looking on the homework and I couldn't find anything quite like this, like the worded the exact same way, so I wasn't sure.
Can I borrow your calculator? One of yours? Thank you. And you could have said no, it would have been fine. I want you to understand. I would not have taken that wrong at all. So if I put in here, let's see, x to the 4th minus 0.3 x to the 3rd. This is very exciting. Minus 2.9 x to the 2nd plus 2.3 x plus 1. I'm going to zoom 6 it. Zoom standard takes it to negative 10, 10, negative 10, 10. Let's see what I see. Okay. So I pretty much see everything. Does the end behavior match with what we would expect? What tells me the end behavior there? From the function, what tells me the end behavior?
The greatest factor is
The greatest degree is 4.
parallel.
There it is. It's parabolic on both sides, yes? In the middle it wobbles because when x gets really small, this actually gets small, these actually get bigger. They dominate and they make the thing wobble in the middle. Okay. I'm asking for the roots, right? The zeros. How did I say it? Zeros. I love it. Okay. How many zeros can you see? Yes. And in fact, what's it look like the multiplicity is at both of them? It's going through pretty straight, yes? Looks like they both have a multiplicity of 1. It's a 4th power, though. How many answers are there supposed to be? 4. So if I see 2 real roots, how many complex roots must there be? 2, because there's got to be 4 answers. It's a 4th power. 4th degree polynomial has to have 4 answers. I see 2 real, there must be 2 complex. Now let me really blow your mind. I'm going to do a little bit more with this. Well, let's do this first. I'm sorry. Let's do what this actually asked me to do. I'm going to show you how to find the real 0. One thing I'm going to do is really cool. Zoom box is my favorite. Have I shown you guys Zoom box? Once? Yeah, I kind of suck about remembering to do the calculator because I like doing a lot of stuff by hand, but calculators are important. So do you see how with Zoom box, if I move the cursor, it becomes one corner of a box. If I hit enter and then I move it down and over, I open a box. And then I zoom in. This is like the CSIS enhance. And now I can just see shit better. Yes? So let's say I want to find this 0 right there. There's 2 of them. I can only find one at a time. I'm going to so I want this expensive ass calculator to calculate something graphically, yes? I want it to calculate the 0. This whole top row is graphical shit, yes? Do you guys see where it says calculate?
Yes.
That must be graphically calculate because the whole top row is graphical. So I'm going to do second, trace, and now I can calculate shit. The last 2 things are calculus, so don't worry about those. Minimum maximum sounds good. That sounds like it could have helped with vertices. So if you read your manuals, that could have helped you with parabolas. If you didn't, too bad. Right now, I want to find the zeros. Yes? So crazily enough, I'm going to pick the one that says 0. And it's going to ask me 3 questions. Yes? It's going to ask me, what is your name? What is your favorite color? No, it's going to ask me the left bound and the right bound. So this is what they mean. Right now, there's an infinite number of x's where the answer could be. I want to give the calculator a little bit narrower range to search. So what this means is, I'm going to put my cursor right on the answer, and then I'm going to hit the left arrow a few times. So I go to the left of the answer, enter. If I put it back on there, and I hit the right, now it says right bound. So I get it right back on, and then I hit the right arrow a few times, enter. Now it's going to search between those 2. And then it says, give me a good guess to get me started. So I'm going to put the cursor right on the answer, enter. And then it gives me the exact x-intercept. Yes? You guys at all with me? Not exact, to be honest, because it probably goes further than this, but, you know, It gives me a good approximation. Sometimes you might see this say like 1.783 e negative 11. That means times 10 to the negative 11, which means 0.000 10 zeros. And that's because, and this is really interesting, there is a class where you would learn the algorithms the calculator uses to do what it just did. Humans programmed this damn thing. At some point, it's based on shit we can do. We just programmed this to do it for us. And there's a math class where you would learn what the hell it actually does. Now, to be really honest, I reached out to TI and I said, hey, I'm a teacher. I just was curious. How did you modify the algorithm? I want to let my students know. And they said, you might be a spy from HP. This happened. I'm like, okay, I'm sorry. They thought it was, HP is another calculator company. So they thought I was trying to get information. That I just always find that so funny. I'm like, no, I'm just a teacher. I just want to tell my students. I'm sorry. Now, real quick, look at this. Look at this little dip. Watch what happens. Actually, let me first zoom back out a bit. Watch what happens if I just change this function a little bit. Oh shit, I changed it too much. That dip is really, really small. Oh no. Am I gonna be able to do it, Jeff? I don't know, dude. Let's see if I get lucky. I almost got it. Okay, wait, let me zoom in. Sorry. Everybody just, sit there and hope that this old calculator dude can do something. Okay, let's see. There's 1 real, 2 real, 3, 4 real. Do you see it? 1 real, 2 real, 3, 4 real answers. So if I just change that last number a little bit, that lifts this above it. So now there's got to be 2 complex answers, because now they intersect in the colorful dimension. Remember? Colorful dimension. Let's stay in the non-so-colorful dimension. Okay. I don't know if you guys are really with me. But it's so cool to see that little dip. Because if I just drag it down, I've got 4 real answers. If I push it back up, I've got 2 real answers. So I must have 2 complex answers. It's a 4th power. It's got to have 4 answers. Yes?
So in this scenario where we have 4 real answers that we can see, we still have 2 complex or not?
No. I can't have any complex. I know I have 4 total answers. And now I see they're all real.
Yeah, okay.
If I move it up just a bit, now I have 2 real answers, so there must be 2 that are complex. Yes. I love that. It's just so cool to see that. That's how that works. Yeah. Slight modifications to a function can drastically change the outputs it could have. It's crazy. All right. I went further than I needed to. I'm sorry. Oh, let me give it back before I steal it. You're like, I'm keeping an eye on you. I don't blame you. Anything else?
We've already went over 9 when we had it written on the board, but do you think we could just go through those again?
So on this one, the inside must be positive. So the inside must be positive. And then you solve it. So if I subtract 5, divide by -1, what happens when I divide by a negative?
It's constant.
True. What happens to the sign?
Changes.
Good. So this guy's domain is all numbers less than 5. Negative infinity up to 5 if you want to write it like an interval notation. Is that cool?
Yeah, that makes sense.
And then logs, I know the range is all real numbers. These guys, the domain is all real numbers, and the range is just dependent on where the asymptote went. We moved it up 2, so normally it's 0 to infinity. I think you said it perfectly, whoever did that one. And now it goes from 2 to infinity. because I just moved it up 2. If it was a negative in front of the 6, now it would be negative infinity up to 2 because now it's been flipped over. Yes? So the more you understand what a graph looks like, the easier those kind of questions are. Domain questions especially. If you just know what a graph looks like, you can figure out what the domain is. You know where the trouble spots are based on the graph. Okay. Someday I'll be evil enough to give a test on the day we get back from spring break, but I'm just evil enough to give us the test on the day after the day we get back.
So why can't, I guess I don't get it yet, why can't we have, the range be anything lower than 0, or anything lower than 2, right? Is that?
Oh, well, first off, let's make sure we understand why a standard exponential can't go below 0, right? So let's build up to that. So if I just have this, not shifted at all, can we investigate why does it make sense the output can't be, well, in fact, the output can't be 0. I can't raise 6 to a number and make the answer 0. Does it make sense? 6 to the 0 power is 1. 6 to anything bigger than 0, becomes bigger, eventually bigger than 6. 6 to a negative number is 1 over, and that can't be 0 because the top is 1 always. So it can't even have a 0 output, let alone a negative output, right? So when I raise a number to a power, I can't make the answer become negative if it wasn't already negative. You with me?
Yes.
Okay, good. And so that's why normally exponentials have, Jeff, you'll be all right. Exponentials have an asymptote right here, which means normally their range is 0 to infinity. If I move things up 2, now it's 2 to infinity.
Okay.
If I flip it, now it's negative infinity up to whatever. Is that cool? Okay. Come on. Yeah, this stuff is not intuitive. It's stuff we made up because back in the day we didn't have anything else to do. Like, we got paper and pens, let's mess with numbers. Thankfully we did, because now we can do a lot more stuff. Anything else? So what all is due tomorrow? Remember what I told you. We did talk about section 6.6, but what did I tell you guys? Does anyone remember? Yes, it won't be an exam. You don't have to have the homework done yet. So you don't have to have section 6.6 tomorrow done. Rearrange the words in that sense. So you only need up through 6.5 tomorrow. You with me? Also, what's due tomorrow? Let me say it like this. What's the only thing that's not due tomorrow? Homework corrections. Everything else is due tomorrow. Quiz corrections, test corrections, if you want to do them. Yes? Is it horrible if you happen to not get them done by tomorrow? Can you still turn them in? Of course you can. You can turn in quiz 1 corrections on the day of the final. Is it late at that point? Hell yeah, it's very late, but if you get enough of the corrections right, you'll get something back. You with me? So the sooner you give it to me, the better. The later it is, the less points I give you back. Does that make sense? So just focus. Don't think about, I gotta check these boxes off. Think about, what do I do to get myself ready for the test? That is always the most important thing. And the great thing, the thing I try to do is if you make corrections, you are studying. You see the method to my madness. Yes? If you do homework correction, you're studying. If you do homework, you're studying. If you, whatever, it's all studying, and they're all things you get points for. Hey, it's like Jeff did those on purpose. That's crazy. And if you're really behind in homework, just start doing every other problem I assign. Because at the end of the day, I could have assigned completely different homework. The problems I did assign aren't themselves important. What's important is the broad range of practice. So don't come tomorrow and have entire sections you did nothing. That's horrible. This doesn't make any sense. Right? So if you're really behind on homework, just stop trying to get every single one done. Do every other one I assign. So if I assign 3 through 30 every third one. Do 3, 9, you know, so jump by 6 instead of by 3. You guys see what I'm saying? Do every other one. Okay, maybe. I'm not gonna be happy about it. I'm gonna say, finish this crazy shit, and you're gonna be like, I'll do what I can, man. Because that's what it is. It's you make it your own thing. By the way, if you are ready for the test, you can certainly head out. As always. But I always get at the end of class, I always get people waiting because they're like, somebody might ask you a good question. Yeah. Oh.